Okay, so this time I will talk about the problem, the castle. In this problem, the difficult part about this, I think, is the implementation. If you understand this topic and you know breadth research, then this question will be sort of easy. So the code on this is a bit longer. And first, I made a nested loop to find all the combinations of the walls, and then I can set each of those to 1. This is a Boolean array. So, for example, here, this is the northern wall, the west wall, the south wall, and the east wall. So then, like, you can test out each different combinations and add them up, and then you will know which number stands for what type of wall. And then after receiving the input, I use this max area function to find the area of different rooms and also find the maximum area. So here I made a visited array, which is a 2D array. It will keep track of the coordinates that we've visited already. So here, if it's not visited yet, you will loop through each of the little grid thing like this. So if you find one that's not visited, then we will add 1 to this room count variable, and then we can do breadth first search to find the area. In this BFS function, I just use, it's basically just a normal BFS, except you gotta put in the details about the walls and where you can go. So here, after receiving the coordinates that you currently are at, you can see it's north, west, south, and east, and if there's a wall, then you couldn't go that way. So here, if there's no wall, and it's not visited, then we mark this as visited and we push this into our queue. And this is same for the west wall, the south wall, and the east wall. At the end, we keep track of all the parts that we visited, and then we add it into this C, and then we return it. So this is how we get area for one room. After this room is visited, then we know that every of the array all the visited array in the room will be marked as true. So then we will keep on going through this loop and until we find one that's not visited yet. That means that this is a new room and we can find the area again using this BFS. And afterwards we compare this to find the maximum area. And then at the end it returns this room count and maximum room area. After this is the most difficult part, I think. And after this, you just create a loop to loop through each of these parts and see which one of them will you remove a wall from. So here, we will check a north wall and check the east wall. So we need to first of all we need to see if there's a wall. If there's no wall, you cannot remove anything from that. And we gotta check if it's the same room or not. If it's the same room and you remove a wall, the area will still remain the same. So you have to find two different rooms. So here's the area sum. It will sum up the area from was between two rooms. So for example, here this is the area of the first room. And since you remove that wall, the area of the first room and the second room will be combined. So this is the second room. Notice how I did I-1. This means that we're moving 1 up, which means it's north. So then we compare this area sum to our greatest recorded sum already. And if it's bigger, then we change the answer to this wall. And then this is the east wall. This time we need to check the horizontal line. So first of all, we need to check if this is there is a wall on the east, and also check if it's the same room or not. If it's different room and there's a wall on the east, then we will add the areas of this room and the room on the east. Then we'll compare this area again with the ones that we've already recorded and see which one will be the right choice. Afterwards, you just print out this final sum because we've already compared all the maximum sums. And you also print out the coordinates that you saved and the directions. And this is it for this question.